Okay, let's take a reservoir. Reservoir, tank, कुछ भी. ठीक है? Let's take a tank. Now it is filling up with water. एक कोई pipe है. Let's take a pipe which is filling the tank with water. And up till when you want to fill it? Up till when you want to connect this pipe to the reservoir? कब तक हम इसे फिल कब तक ये पाइप कनेक्टेड रखना चाहते हैं हम इससे? Till no, till it does not spills. Yes, if we want to fill the tank, we will connect the pipe to this reservoir till it does not spills. Right? So what we'll do for that? What we'll do for that? What can we do for that? Till it does not spills. बिल्कुल एक बूंद भी बाहर ना गिरे. What we'll do? और एकदम से हम पाइप डालें. So what can we do for that? Yes. कैसे? क्या करना पड़ेगा उसके लिए? करना how you will check that कि बिल्कुल भरने वाला अभी है और ऐसे how will we check that? बिल्कुल simple, just think very simple concepts. बिल्कुल simple जो तुम करोगे. अब ये है like let's take this reservoir, right? हमने यहाँ पे पाइप लगा, okay? And I don't want that the water should spill. What will I do? हर थोड़ी देर में गिर तो नहीं रहा, ऐसे तो करेंगे, है ना? You will do this thing. I'm just asking very simple thing. सोचते क्या करोगे तुम? You every time हर थोड़ी देर में you will check. अभी इतना नहीं, हर थोड़ी देर में we will check. अभी और थोड़ा सा भरना रह गया. That means we are checking the depth of water at particular or at different time intervals, right? We are checking the depth of water at different time intervals. Now it is this much filled. Now it is this much filled, right? So we will check the depth. Let's say this is at time t1 we are checking, at time t2, at time t3. So at different intervals, when with respect to one variable, two variables are there. One is the depth here, other is the time. With respect to different times, at particular instants of time, we are checking what is the change in the depth, right? At particular instants of time, we are checking what is the change in depth. So we are checking the change of one variable with respect to other. That is derivative. Rate of change of one variable with respect to other. Okay, simple. So derivative is rate of change of one variable with respect to other. Okay, and this is a daily life situation where derivative is applied. और भी बहुत सारी situations हो सकती हैं. Can you give an example? Where derivatives are applied, you must have learnt in physics also. Yes, very good. We are checking if we want to move from one point to other. If we want to move from one point to other, we are checking the distance at particular time intervals. At t1, we are at this point. At t2, we are at this point. Let's take it as C, D. At t3, we are at this point. So again, we are checking the distance after particular time intervals. So there also, if we want to study that this much distance we have covered in this time, this much distance we have covered in this time. So we check the rate of change of distance with respect to time, right? That means again, rate of change of one variable with respect to other. So in many conditions, in many life situations, we are using these derivatives. Rate of change of one variable with respect to other. So this is rate of change of one variable with respect to other. Right? Now, let's talk about the curves that you were talking of. Let's take a curve. We have to find out the derivative at any point of this curve. Right? Derivative at any point point of this curve. Curve is, again, it is specifying some condition. According to that condition, we are making this graph, right? ये भी तो एक graph है. According to a condition, this distance is moved in this much time, this distance moved in this much time. So this is also satisfying a given condition. This is also a particular type of graph. Similarly, we have this. This is a curve. Now, we have to check the derivative at this point of time. So what do? We make a tangent at this point, right? Yes, we make a tangent at this point. T3 is for this. We make a tangent at this point and we find out the change of what two things are here. Whenever we are talking of a curve, we talk about the x and y axis, right? So what two things are there in this at this point? Some x will be there, some y will be there. We will check the value of y with respect to x, change in y with respect to x, right? So if we are talking about the curve, then also at any point, if we are finding out the change of y with respect to x, then that is the derivative. And it can be x with respect to y also. That is, in our syllabus, we will be taking x as the independent variable and y as the dependent variable. Because when we are learning about functions, we are learning it like this, right? When we put some values of x, we get some values of fx. So y is dependent on x, है ना? So x is taken as independent variable and y is dependent on x. So y is taken as dependent variable. So derivative may be, when we are finding out the derivative, we are finding it out like this. Derivative, that is change of y with respect to x, and change we give as dy by dx. So it is change of y with respect to x. Okay? Always, whenever we are calculating the derivative, whenever we are calculating the rate of change, it is of dependent variable with respect to independent. Okay? Dependent variable with respect to independent. Like we took here. Independent was t. At particular time interval, we are taking the change in depth. Particular time interval where we are taking the change in depth. So time was the dependent variable and depth is the independent variable. So we can take depth as h dh by dt. ठीक है, तो जो भी ऊपर लिखा है that is dependent and here it is independent, right? Now when we talk about the curve in x or y, we are having some function y equal to fx. We are finding out the change in x with respect to y. This is given as dy by dx. Okay. Now, dy by dx, if we find out, it will be equal to, when we calculate it by completing the triangle, so that will be equal to slope of tangent, right? So this is the next thing that we can talk about derivative. Firstly, in simple words, it is rate of change of one variable with respect to other. And if we talk about it in terms of slope, so we can say dy by dx is slope of tangent at any point right? What is slope of tangent? Tan theta. This is dy by dt. Slope of tangent हमने यही तो पढ़ा ना? We have learned it in straight lines, that is tan theta. So this is dy by dx. So you can also say it as slope of tangent at any point of a curve, or simply it is rate of change of one variable with respect to other. Clear? Derivative is clear. अब कोई अगर definition पूछेगा, कोई अगर पूछेगा what is derivative, so you can tell it clearly. Have you understood this? Yes. Note it down. Done?
Yes.
Now we are coming to the definition. Write down the definition. Suppose, write down definition. यही derivatives की definition है. After this, you write down. Suppose f is a real valued function. F is a real valued function, and a, small a, is a point in its domain. A is a point in its domain, full stop. The derivative of f, at a, the derivative of f at a is defined as limit x tends to 0 f a plus h minus f a upon h. H tends to 0 f a plus h minus f a upon h. And in general, this is what we are taking, we are finding out the derivative at some point. Abhi aayega. And we denote it as f dash a. In general, we give it as f dash x. If in terms of x, in terms of variable, if we are finding out the derivative, it is x tends to 0, f x plus h minus fx upon h. This is in general. If we are not taking any point, if we want to find out the derivative of any function which is in terms of x, so it is fx plus h minus fx upon h. Now, how do we get this? Let's come to this. Let's take a curve. We are taking a curve, let's say this one, and let's take any point P on this curve, A and A. Right? This is any point P which is whose x coordinate is A, and if we are putting x in the function, we get FA. That is, the image is f of A. And then we are taking another point Q, which is with some small change, right? And what small change we have taken here?
H.
H. That means the small change is A plus H and f of A plus H. Is this clear? What we have done, we have taken 2 points. P point is having the coordinates A and the image of A, that is FA. Q is somewhat at some distance, let's say A plus H. How we can take it at any side? Bilkul. Yes, you can take it like that. Now what we have to find out, we have to just understand how we have got this. Okay, so for this we are just dropping perpendiculars from Q and P, and let's make it. This is x-axis, this is y-axis. And what else we are doing is we are making a tangent at point P. Okay, let's make a tangent at point P, which is making an angle, let's say theta, with x-axis. P point P, we are drawing a tangent which is making an angle theta with x-axis. What will be? Let's just name them M, N, O. What is the distance PM? Can anyone tell me what is the distance PM? ON होगा, तो what is ON? See, this is A plus H. A plus H means up to this. Oh, yes. It will be A plus H, complete distance, and this is A. So we have A plus H minus A, that is H. Right? What is this distance? Let's just calculate QM. What is QM?
F A plus H.
When we are talking about a curve and a point is here, okay, having the coordinates x, y, what does this mean? That is the distance from origin on x-axis is x, and distance on y-axis is y. Is this clear? If the point is having the coordinates x, y, that means on x-axis this distance, perpendicular distance, it is x, and this one is y. Similarly, we have this. Now, when we talk about O will be this one. Let's take it as P. R. Let's take it as R. When we talk about OR, what is the distance OR? We have dropped the perpendicular from point Q. So OR distance will be the x coordinate. Okay? X coordinate is A plus H. Similarly, if we talk about distance ON, ON means let's come to the perpendicular. The point is A. So this distance will be A units, x coordinate of P point. And we have to find out NR. So NR will be A plus H minus A. That is H. Similarly, if we come to this distance, QM we have to calculate. So what is QM? Why are we calculating QM? Or why are we calculating this NR and QM? Because we need to find out this theta. Is this clear to you? Both will be theta because these are corresponding lines. So angles are equal if the line, these are parallel lines. So corresponding angles are equal in case of parallel lines, right? So if we are calculating this, what will be this value? Complete one is y-axis. So y-axis, the point is FA plus H. This much is, let's come to this part. So these distances are equal. So the distance is FA. We have to find out QM. So it will be complete minus this one. So FA plus H minus FA. Okay. Now we have to find out the slope. Slope is, we all know slope is tan theta.
But F common लेके उसको minus नहीं होगा.
F cannot be taken common because F is a function, right? Function is applied on some variable, we cannot take it common, okay? Slope is tan theta. So we can find out whatever we can find out from here, since theta is same. So if we find out tan theta, it will be QM upon PM. यही तो होगा tan theta. Tan theta means perpendicular upon base. So from triangle, let's take this triangle. If we join these PQM, so tan theta will be perpendicular upon base, right? So this is QM upon PM. QM upon PM. And we get it as FA plus H minus FA upon H. Right? Tan theta we have got, but we need to find out the slope at point P. Derivative we have studied, slope at point P. Now if we apply limit h tends to 0, where will Q go? If we apply limit h tends to 0, where will Q go? Can anyone tell me? If we apply limit h tends to 0, will the position of Q change? बिल्कुल है ना? It will coincide with P. Yes. Because h tends to 0, so Q point will coincide with P. That means if we are applying limit h tends to 0. So we will get slope of tangent at point P. ठीक है? And this is the derivative of function at any point. Okay, is it clear now? So this is the geometrical interpretation of derivatives. We have calculated the slope using tan theta. Slope we all know is tan theta. By using the triangle, we have calculated the slope, that is fa plus h minus fa upon h. And then since we need to find out the slope at this particular point P, so let's put limit h tends to 0. And as limit h tends to 0, Q point will coincide with P point. And we will get the slope of tangent at this point P. और वही हमारा derivative है. This is what we have written as the definition. Derivative of a function at any point is limit h tends to 0, fa plus h minus fa upon h. Clear?
Yes.
You can just note it down. Now there is a special name given to this when we are finding out the slope of tangent by using this property. This is first principle. And the question is, find out the derivative of the given function using first principle. ठीक है? Find the derivative of given function using first principle, and in that case we will use this general form. Okay, we'll use this general form because function will be given in terms of x and y, and we have to find out the derivative using this general form, which is termed as first principle. So we first of all will be taking some questions, and after that we have direct formulas for derivatives. So afterwards we will be using direct formulas. Okay, but from where have those formulas come? This is the concept. Okay, so that we will be doing. Have you noted this down?
Yes.
So one question we are taking of first principle. We can write it as f dash x also, or we can denote the derivative as dy by dx also, right? Or you can also denote the derivative as y1 if we are doing the first, or you just this is in class 12. We are taking higher order derivatives also, so dy by dx can also be written as y1, or it can also be written as y dash, or it can also be written as d of fx upon x, right? Derivative of fx. Fx means y itself. So d of fx upon dx. So any in one of these ways you can denote the derivative. And this is limit h tends to 0, f x plus h minus fx upon. The question is, find out the derivative of sin x using first principle. Okay? So we have to apply this property, limit x tends to 0, fx. So we can just write it as fx because our property is in terms of fx. How? We know this by formula. Ki sin x, derivative of sin x is cos x. But how has it come? That we will be taking using first principle. First of all, what you do, fx is this. What else we need here? We need fx plus h, right? That means when the in place of x, the variable is x plus h. What will be the function here?
Sin x plus h.
Is it like this or is it like this? Which one is correct? Second one. So be very careful whenever we are writing down the function. This is not correct, right?
Yes.
Because x is the angle here. So whatever change we are making, that will be in the angle only. ठीक है? ये अलग हो गया. This is sin x upon h is there. So this is different. Okay. So this one is correct. That is sine x plus h. Now you just have to put the values. F dash x equal to limit h tends to 0 sine x plus h minus sine x upon h. Now, we all have studied in limits that we apply the limit whenever the function is in its most simplified form. Is it in its most simplified form? No. So what will we do to simplify this? Indeterminate आ रही है अभी तो ये. What will we do to simplify this? Yes, we can. We can apply sin a plus b here, and what else? थोड़ा और simple हो जाएगा. If we apply h tends to 0 directly नहीं रख सकते because it is indeterminate 0 upon 0 है ना. So we have to simplify it first. So sin we can apply sin a plus b here. ठीक है? This is one method. Another method sin c minus sin d. That will be more simple. Then so we are applying sin c minus sin d. And we all know the formula for sin c minus sin d.
2 cos x
Yes. Sin c minus d by 2 upon h. Okay. Let's just cancel it out and we write it in simplified form. This is limit h tends to 0. We get it as h x plus cos x plus h by 2 and 2 is there sin h by 2 upon h. Now what do we do? Yes. Now what we can do here? We have got limit 2 cos x plus h by 2 sin h by 2 upon h. If we look at the limit, what do we see from here? We have learned something in limits. कुछ फायदा नहीं पढ़ाने का.
mn की फॉर्म में वही तो पढ़ाया था लिमिट में.
As we see this sin x, we will try to make it as limit h tends to 0 sin x upon x. बहुत ही important geometric limit that we have studied. Limit x tends to 0 sin x upon x equal to 1. Right? So wherever we have got sin x in the limit, we will try to make that same thing in the denominator. Right? So we have sin h by 2 because this limit becomes 1. So because it is sin h by 2, so we will try to make h by 2 in the denominator. For that we can take this 2 to the denominator. ले सकते हैं ऐसे या अलग से 2 से multiply 2 से divide भी कर सकते हैं. Anything you can do, right? So we are writing it as limit h tends to 0 cos x plus h by 2 sin h by 2 upon h by 2. This 2 comes to the denominator, right? Now we have learned about algebra of limits. If product of two functions is there, we can write them in separate limits. So this is limit h tends to 0 cos x plus h by 2 limit h tends to 0 sin h by 2 upon h by 2. So this limit becomes 1 by the property, and here if we are applying the limit, what do we get? This becomes 0 cos x into 1, and we get the derivative of sin x as cos x. So this is how we have got the derivative of sin x as cos x by the property of first principle, right? और अब हम इसको आगे फॉर्मूले की तरह यूज करेंगे. Clear? Now your homework is to find out the derivative of tan x with respect, yes, with respect to x using first principle.
cos x का हो जाएगा minus x.
Whatever is that, you have to find it out using first principle. Okay? So tomorrow I'll check it on Monday.
लेकिन मैम